Okay, so here's the summary of TCP. On-path and man-in-the-middle attackers who can observe your TCP connection can just totally screw you over. They can terminate the connection. They can inject spoofed data. They can observe all the data. And this threat remains today. There is no, this is still true today. And then there's blind spoofing, where off-path attackers could attack you if you used bad initial sequence numbers. So that's now fixed today. Every modern computer now uses random TCP initial sequence numbers. And so fortunately, blind spoofing problem has been fixed. Just beware, though, because sometimes old security problems come back. Like the ghost of blind spoofing came back in 2016 when someone added some feature to TCP that was doing some stuff and turned out to have the consequence that it allowed an off-path attacker to send some packets to a host, and there was a side channel there that allowed them that leaked some information that allowed them to infer things like sequence numbers, so it allowed them to make a guess at a sequence number, and there was this complicated way you could send a handful of packets and tell whether your sequence number was close to right, was within a window. Then that eventually allowed an off-path attacker to infer sequence numbers, and then ta-da, blind spoofing was possible again. So that was fixed, but it's easy to, when you have a super complicated software thing, it's easy to have these problems arise again if you're not really careful. So that's why it's good to know about these threats. All right, so that's the basic overview on TCP. Any questions before I move on to next protocol? Yeah. Doesn't know the sequence number. Right. The ACK has a sequence number, and it has the server's initial sequence number, and the attacker doesn't know that. Here was the problem. This packet from the server contains the server's initial sequence number, the value y. That's not sent to the attacker, and because the attacker's off path, the attacker can't see it. And then this spoof packet needs to include y. How is the attacker going to learn that? That's the big problem. Yep. Yeah? No. So HTTPS, if you use websites with HTTPS, then what that's doing is to deal with these problems in TCP, all the data that's sent is encrypted and has encrypted and uses a message authentication code. And we'll talk about that when we get to the web security section. But HTTPS is layered on top of HTTPS. I'm sorry. HTTPS is layered on top of TCP, which means that the data, the payload, is encrypted, but the TCP headers are not. So you can still do these TCP injection attacks. It's just that they'll be refused by the recipient because they won't have the right message authentication code. Okay, so that's the defense we have today against this, is use cryptography at the application layer. And then you don't have to worry about whether TCP is secure or not.